Thanks for joining us today for this session on cloud rendering at Walt Disney Animation Studios. My name is Usman Shakil, and I'm a solutions architect with Amazon Web Services. And along with me here today is Kevin Constantine. He's a senior systems engineer at Walt Disney Animation Studios. So last year, at one of these stages, one of these rooms at our reInvent conference, I presented a session on all-in cloud rendering pipeline. It was me and a couple of my colleagues, and we thought that it was a pretty decent solution for customers who wanted to do an all-in rendering pipeline on the cloud. Guess what? My friend Kevin was in the audience. And just like we all Amazonians do, we go to our customer and ask for feedback, and so I did. And I was told it was a toy presentation. Funny, right? Although, just to let you guys know, I think we launched somewhere around close to 3,500, 4,000 cores. And it was a pretty decent rendering pipeline. We were able to create some renders in the end. And it was a live demo and showed the rendering pipeline at a pretty good cost-effective way. But I thought that why don't I work with my customer, with Kevin, and work on a realistic pipeline, which is not a toy demo, right? So we embarked on this sort of say test or proof of concept, if you will, together on this. That what can we do? How much can we push in terms of scale to get to a point where it is a realistic rendering pipeline in the cloud? So just a quick bit of a background. When we talk about rendering, right, there are many different verticals, industry verticals, if you will, many different workloads that are doing rendering. And who are these customers? Where are they from that are using AWS in terms of rendering? Obviously, the visual effects and animation companies. There's stuff around marketing. There's a lot of stuff that happens in marketing videos, stuff like that. Theme parks is another great use case. We have a lot of customers that are doing animation, visual effects for theme parks type of rides. There is utility in manufacturing. We see that even companies have these virtual catalogs where they're not really putting any real inventory. It's really just virtual catalogs. You order an item and basically off they go, and they create that item, or it's manufactured. Gaming has a great utility for rendering. Life sciences, especially in drug design, structural bioinformatics, and engineering and architecture. So all these different customer types are actually using rendering type of workloads. So in this particular session here, we're going to try to make a film in the cloud. So visual effects and animation, that's the focus here. So a very high level sort of walkthrough of what a rendering workflow looks like. Right? It's a very high level, and again, I hope Kevin doesn't laugh at me that I'm making it really high level. But on one side, there is the modeling component where you have your graphic artist, working on some workstation-based graphics tool set where they're creating the blueprints, they're creating the art, etc. They upload it into some storage, or they have the storage attached. Then there is a back-end rendering process that actually goes through and generates these frames. And then there is composting, where you have multiple different graphics that are rendered or frames that are rendered to create a particular shot. There is obviously the asset management piece on top of it, and collaboration and task management. So yes, I'm making it super simplistic just to kind of give you the lay of the land here for those who don't have a background in rendering. But what we're going to focus on here again is the back-end rendering, right? The highly scalable distributed application, or we're going to try to make it highly scalable, that distributed back-end application for rendering that actually generates these shots. So this is actually a chart that I borrowed from Kevin again. This is a realistic, real chart. So what it really talks about is the 13 months of making a movie, a feature animation, right? So as you can see, there are sort of highs and lows in that. I mean, it's a distributed type of a workload. And what's important is, if I can move this, yes, right here. So that's the green line there shows the on-premises capacity, right? So what you can see is that while they've really scaled for or sort of capacity planned for, you know, an animation production that they're making, they're obviously going to hit a point where there is going to be excess or extra capacity that they're going to need, right? And that goes very close to the release date, or sort of like in the third, fourth month of the release cycle here. And that's the sort of crunch time. What happens at that time, right? And talking to Kevin, I found out that, you know, quite literally there is a lot of push and shove in terms of, you know, how can I borrow some resources, some cores from here, from there, even quite literally physically shipping these things, you know. That's in the presence of the cloud should not happen. So basically, if you look at where cloud comes to the picture, you know, with the scalability proposition, just if you take just the scalability proposition, that can be a great application right there. So while the initial sort of phase is where there's a lot of initial work that's happening in terms of creating the graphics, the textures, and all those good things, you know, when it comes point when it's crunch time, the cloud scalability proposition can definitely be a great utility here. Specifically, for those who know, you know, how this whole workflow works, basically the graphic artists, they submit their jobs, the back-end renders, they go home, or they want to see it as soon as possible, right? Because when they come back, say they submit a job at nighttime, they come back in the morning, they want to see the job done. So the faster that's done, the better it is, because what happens is, since it's a recursive type of a process, this back-end rendering, you know, they could actually start a new run if there is additional things they like to do, like changes in lighting, etc. So quickly, a tale of two customers. Again, pointing back to the last year presentation I did. So in this rendering type of workloads, I've come across two types of customers. One is a boutique studio, a very small scale studio that we tried to be last year, or we pretended to be, right? Where basically it's all project-based workloads. And obviously then there is large scale customers such as Walt Disney Animation Studios, right? So what you find is there's a lot of similarities, first of all, in terms of the workloads, but there are some contrasts. So first of all, in terms of on-premise hardware, what you see is there is very little or no investment in the case of boutique shop. Obviously, you know, they don't have a whole lot of investment that they can build these large data centers. Whereas in the case of large animation studio, you're going to see a significant infrastructure investment. Then we talk about software licenses like render engines, plugins, schedulers, and all those good things. And what I find is that a lot of these large customers of ours don't really have any licensing issues, whereas the small scale boutique studios are going to have, say, limited licenses that kind of limits them in terms of how they can scale on the cloud. Then the project structure in both cases is basically, yes, there is a project, whether that be a full-length animation or some kind of an advertisement type of a thing, VFX, et cetera, that they're working on. But needless to say, it's all project-based. Times and resources is a big thing in both cases. Everybody's under budget constraints, want to do things cheaper, quicker. It's a highly compute-intensive type of a workload. We all know that, right? Then in terms of infrastructure efficiencies, what I found talking to some of my large customers was that, you know, given that these data centers are built at keeping in mind one single workload in mind, basically they've come to a point where they've achieved very high levels of efficiencies. The result is that the cost is really optimized. So when I try to do a TCO analysis sitting with Kevin or, you know, his colleagues that, hey, does it make sense to run in the cloud or not, right? We run into some challenges because this infrastructure is optimized to run one single workload. And then security, that's, you know, very important, whether that be a small scale studio or a large animation studio. So they both ask us the same thing, interestingly. They want to be able to spin up thousands of cores on demand. And we'll talk about what does this thousands mean, right? Last year we did 3,500. Without any upfront investment, and they want to be leveraging the most up-to-date configurations. They don't want to be tied to specific hardware. They want to get the latest and the greatest, which is out there, and they want to treat it as a disposable infrastructure. That is, you run the infrastructure for the amount of time you're going to run your renders and then kill it. Don't have to pay for it. And they both tell us the same thing, that on AWS, they are able to get a price point which is under or about a penny per core per hour. And we'll get into the details of that as well. They're able to build a project-based disposable infrastructure. They have access to very large memory configurations to do very large-scale, high-resolution renders. They have access to thousands of cores whenever they need. There is no upfront investment, and there is very easy collaboration. And most of all, there is a pretty rich ecosystem of software providers. All great things. But when the reality hits, there are challenges. And we're going to discuss what are those challenges, right? But I'd like to really point out all these challenges, they kind of root back to one thing, data and content. We see that content data sets are growing large. High resolution images, files, 4K files, HD, et cetera. It's basically just increasing the amount of storage that's needed, and not just the storage, but the bandwidth that's going to be needed to transfer that data or content back into the close to the compute environment. So what you're going to see is issues like I'm going to need a shared file system everywhere if I want to run a hybrid type of a workload. There is going to be latency because my data is on premises and I'm trying to run my computation on the cloud. These are very large data sets, as I pointed out, and if I want to scale truly at a cloud scale, then it's going to be a lot of instances trying to write and read the same data set. So we're going to walk through some of the challenges here. Where we are, first of all, in terms of the solution, in terms of these different things that I talked about, what different solutions are available out there, what is still a challenge, and then I'll pass it over to Kevin to talk about his experiences. So let's first take scale. So EC2 Spot instances. I don't know how many of people here are familiar with Spot, but just a very quick recap. So EC2 Spot is a mechanism that we provide our customers to be able to bid on our overage capacity. Obviously, the AWS cloud is big. The scale is large. We have customers from all different verticals, like large, small, enterprises, you name it. Everybody running compute intensive, or there are different types of workloads on AWS. So we have to manage the capacity for them, make sure that when a customer comes to us, they request an instance, they get that instance. Now for that, we have to capacity plan, and we make sure that there's this buffer that we have, in terms that in times when people are asking for a large amount of capacity. It doesn't hurt to be able to use that capacity or put that capacity at use for our customers. So we give our customers the control via the APIs to be able to go and actually bid on that overage capacity that we have. So great, that means that maybe my customers can actually go and get access or have access to a large amount of compute capacity at a very cheap price, okay? But in order to do that, historically, these are some of the things that I listed that you had to go do. So the biggest piece here is management, right? So think about if you're trying to launch thousands of these cores and you're able to bid on a single instance, well, good luck with that. There are tool sets like auto-scaling and all those great things that will help with that, but still the management piece of that is very hard. In AWS land, we call it undifferentiated heavy lifting. And that's what we're trying to do. That's the whole goal here, right? That how can we take care of this undifferentiated heavy lifting so that you, our customer, can focus on your core business. So we launched a new feature set called Spot Fleet. Very interesting. Basically, it takes care of this undifferentiated heavy lifting when you're trying to use the EC2 Spot model. Specifically, you mention a target capacity, you specify the maximum bid price that you want to pay, and you specify the launch specification, which could be, hey, what type of machine image I have, what type of software I want to deploy, and my VPC configuration, etc., and an identity and access management fleet role, then it gives you the capability to actually define a compute unit. So in this example, as you can see in the chart, let's say if it's an R3 2 extra large instance type that has 61 gigs of RAM and say 8 virtual cores, we call it 1 unit. I mean, obviously you could define whatever you want to call a unit. And then any instance type that is, say, multiples of that will be the actual multiples units. So for example, R3 4 extra large will be 2 units, and then R3 8 extra large will be 4 units, right? That's really dependent on the core and the memory. You use Spot Fleet, and in your configuration or in your launch command, you actually specify the price that you want to pay per unit. And what Spot Fleet does is it actually takes that and it will launch all these cores or instances that you requested in multiple different instance types in multiple different availability zones. So one of the key things there is that it does that intelligently so that there is the least amount of chances for termination in the Spot model when you're launching with Spot Fleet, and you get the best price point for that. So a great use case there. So going back to the scale problem, right? We talked about large scale. So what really is large scale? Is it tens of cores, hundreds of cores? How many thousands of cores is it? So talking to Kevin again, I found out that Disney Animation has a footprint or a render farm of somewhere around 50,000 cores, right? So we said, okay, let's try to push the limits of the scale here. And with Spot Fleet, we launched somewhere around 40,000 cores in the EC2 Spot market. And Kevin will talk about how we did that, how long that lived, and the pricing and stuff like that around it. But that kind of gives you an idea of what kind of scale you can achieve. The second challenge is licensing. Obviously, I talked about for Disney or for some of the large studios, licensing is not a huge challenge because first, they have sometimes their own homegrown or home-built sort of software that they're using. And if they're using some other third-party software, they probably have unlimited licenses, right, or some kind of an arrangement. Whereas for a boutique studio, this is still a challenge, so I want to at least point it out. What I'm seeing is that there is a lot of push towards more elastic licensing models, right? I've talked to so many different vendors out there. ThinkBox, I listed them in there. Specifically, people are looking at an elastic licensing model where they can charge, more elastically on an hourly pricing model. The third challenge is, as I talked about earlier, you have a lot of this data or content set. How are you going to migrate or move it over to the cloud, right? So that's where we have a bunch of different solutions from, depending on if you want to move all your stuff into S3, the object store, or EFS. We have solutions, partner solutions like Signian, Dispera, File Catalyst, Data Expedition, et cetera. Even S3 multi-part upload, some of the scalable type of solutions. And then if you want to do shared file system type of stuff, right, we launch Elastic File System, and we'll talk about what we were able to find in this particular proof of concept. Then there's Lustre, Gluster, there's Avere. So depending on really if it's an all-in cloud type of a workload or a hybrid type of scenario, what you want to do. And to aid all of this, there is AWS Direct Connect, which is a capability for you to directly connect with AWS regions. So just to put into perspective, a few of these solutions in terms of the storage solutions, right? If you want to have a shared file system everywhere, for example, on your right-hand side, you can see the on-premise storage. You can see the Avere FXT. For those of you who are from this sort of background and understand what Avere is, basically it's a sort of think of it as a storage cache. So in this scenario, I've actually tried to show 3 different scenarios. One is that you're trying to do a hybrid workload on-premise where your storage lives in S3, then you put Avere FXT in front of it. The other scenario is reverse of that, where you have your content, et cetera, living on premise, and you have, say, an Avere virtual FXT in the cloud, running on EC2 instances. You can have a scalable fleet of workers that are fronting your Elastic File System or basically hydrating your Elastic File System initially. Then Lustre is another example, which is a shared file system that could kind of feed off of S3 directly. And there are many others in this context. So a quick few things on Elastic File System. Basically, it gives you a shared file system everywhere. It's designed to support petabyte scale file systems with high durability. There is actually a session on Elastic File System, so I won't spend a whole lot of time here. If you guys have time, feel free to go there. It's highly applicable in this context. But really a point I like to make is that there is, as the storage grows in the case of EFS, so does the throughput or performance from EFS as well. One of the other challenges that I talk to different customers, and both large and small customers, is the idea of distributed workforce, right? So you have your graphic artists that are all over the globe, right? How could we really use storage at one point, or say in multiple different locations, and can actually stream the applications or workstation applications back to them? There are some solutions there. I wouldn't say that we're quite there yet, but we've done quite a bit of progress since last year in terms of the solutions that are available there, specifically in the form of interactivity, low latency type of solutions, some of them listed here. All right. We talked about disposable infrastructure. So with Amazon Machine Images and CloudFormation templates, basically you can generate these templatized environments. We call them CloudFormation stacks that can be scaled basically depending on the needs by running an update stack. And once you're done with your project, you can simply call terminate stack on it, and the entire environment is gone. So that kind of gives you an idea for a disposable infrastructure. Security is of paramount importance. So the Motion Pictures Association of Americas has a cloud-based application guidelines for content security that just launched August of 2015. We worked closely with them and our compliance teams internally, and we mapped our existing audit reports from different compliances like our SOC 1, SOC 2, ISO 27001, mapped those directly to the guidelines that MPAA has. And what we found was that basically we align to these guidelines that MPAA provides for all content types. So very quickly, a sample architecture. So on the right-hand side, you have on-premise storage. So first, I'm going to focus on all-in cloud pipeline. On the left-hand side, you have your AWS environment with S3. So basically, you could think of using AWS Direct Connect to move your content into S3, and we talked about other ingest options. Then you can use a fleet of even EC2 Spot workers to hydrate your Elastic file system. Or you can build a virtual FXT, a VR virtual FXT in front of your on-premise storage. And then you have a pipeline or a license manager in case you are running into Elastic, into licensing. You can run a license manager on EC2. And then you can have a fleet of EC2 instances, whether that be on-demand instances or Spot in our case, and really scale it depending on how much you need. If you want to do modeling or 3D graphic artist type of work, I mean, you could do that through some of the solutions I listed above earlier, including our Amazon AppStream, Teradata, PCORIP, etc. So that kind of gives you an idea for running an all-in cloud rendering pipeline. Now, there can be multiple different flavors of it, right? Really depending on your different use case. Now, this specific one talks about a hybrid type of a scenario where you have, again, on-premise storage, same type of model for moving the data content set in there, and you can launch an auto-scalable or an EC2 Spot fleet there. And then going back, if you want to run a render farm on-premise as well, basically you can run it on-premise with an AVIR FXT option, which fronts S3, and then you can have your pipeline or a scheduler running on-prem, which is controlling your EC2 render farm as well, because it could all be an extension of your internal network in the form of a VPC. So with that, let's make a real film.